The basic gist of it is summarized on the screen right now. Y equals f of x is an original function. Y minus k equals f of x minus h is a transformation of that original function. We call this new function the transformed function, the result of the transformation. We could rewrite this, instead of saying y minus k equals f of x minus h, we could rewrite it as y equals f of x minus h plus k, which I've got on the side screen. If you're watching this on video, all I'm talking about is the fact that you can move that k to the other side. And it's probably preferable, everybody, to do so. It's probably a better idea to write y equals rather than y minus k equals. Regardless, you have to use this, what I call a template, this y equals f of x minus h plus k, or this y minus k equals f of x minus h. This is what I call the template. This is what you have to match the function that you're interested in to this template. And you have to be able to determine the value of h and k. H is a parameter that results in a horizontal translation, which means left or right. K is a parameter that results in a vertical translation, which means up or down. Again, looking back at Math 20-1, h and k are like p and q respectively for quadratic functions. The difference, of course, is here it could be a quadratic function, it could be a linear function, it could be a trigonometric, a logarithmic, an exponential, or it could just be lines on a grid that I've decided to draw that don't really maybe have a definable equation. The bottom line is to make this as general as possible. When the parameter is negative, the shift is in a negative direction. So if h is negative, that means the horizontal translation is negative, and negative in terms of horizontal is to your left. If h is a positive number, the parameter h is positive, well then it's a positive translation. It's in a positive direction, and for horizontal, positive is to the right, to your right. You know, and I can go through the same thing with k. If k is negative, then it's a negative vertical translation, and negative in terms of a direction vertically is down. And if k is positive, then it's shifted up, because up is a positive direction vertically. The result is that your mapping is always whatever h is gets added to x, and whatever k is gets added to y. The reason why it's added is because that would take into account if those parameters are negative or positive. So think about this for a second. If h is negative, let's just say h as an illustration is -3, that means things get shifted left 3. Well, if you use this pattern here, this template at the bottom, it says that the new x coordinate will be x plus h, which is x plus -3, which is the same as taking 3 away from x. It's shifting it to the left. You don't need to memorize this mapping at the bottom, but I think it's important that you could build it if you had to or you were asked to, and you understand it if it's in front of you. So I'm just going to start with the textbook problems. Does anybody have any questions you'd like me to go over from questions 1 or 3 in the textbook? Seeing none, what about the multiple choice problems? I guess I will address number 2. How many of you figured out what the issue with number 2 was? The kind of wrinkle or twist or trick to it. See, if you're in a rush and you read this question and you look up top, you see that we have y equals f of x, and it turns into y equals f of x minus 1 plus 3. So there's that thing I was talking about earlier. I think it's, for me anyway, and I think for most of you, it's better to write y equals. So rather than writing y minus 3 equals, I've added 3 to both sides. I've gone from y minus k equals to y equals something plus k. It's very easy to see, well, there's a number of things I can do here. One is to say, looking at this, you should understand it's shifting 1 unit to the right. How many of you see that it's shifted 1 unit to the right and you never ever ask yourself what h is equal to? You just say it's shifted 1 unit to the right. That's probably a lot of us. But you could look at this and compare this thing that I've written here to the template, and you could see that if it's f of x minus h and if it's f of x minus 1, h is 1. So we could do that. I don't think it's really necessary. Looking at this, I hope everybody sees that this is shifted 3 units up. And you need to, and that means k is positive 3. But the issue here when I say this, it can be confusing because I'm writing this stuff underneath this function. What's really happening is the original function is being shifted 1 to the right and 3 up. And that means that the mapping is a point on the original function maps to x plus 1 comma y plus 3 on the new function. And if you just read this question haphazardly without any care, you see this point, where is it? Right here. And you go, oh, well, if I shift that point 1 to the right and 3 up, I'm going to get the answer. I'm going to get, let's see, negative 2 plus 1 is negative 1. 4 plus 3 is 7. And you're writing an exam and you choose this, and I mark it wrong. Because that point, negative 2 comma 4, is not a point on the original function. You're told it's a point on the transformed function and asked what was the point before it was transformed. So what you are told is that this is negative 2 comma 4, and you have to determine this. Now you can do it with mapping, which is a very algebraic, precise approach, or you can just say, if, and I'm thinking a number line here, if the x coordinate ends up being negative 2, after it's been shifted 1 to the right, then it must have started at negative 3. Which takes me to either C or D. And then I can think vertically, if the y coordinate after the translation is 4, and that was a result of shifting the original 3 up, then it must have started at 1. You know, what you could do as well is the following. This is maybe overkill, but it works. Negative 2 is x plus 1. And you can solve that for x and get negative 3. Then you could say 4, the new y coordinate is the old y coordinate plus 3, and you can solve that for, excuse me, the old y coordinate. Thank you. Thank you. All right. So if you were on top of your game here and you got a good handle on this, it's pretty easy marks, really, I think. This is, you know, I don't want you to walk away from this quiz going, oh, this is the difficulty of this course. It, of course, can get more difficult, and it will get more difficult. So this is on page 6 of your unit handout. And what we are asked to do here is, it's key in understanding the conversation that Ian and I have been having over the past couple days about f and what f means. What we're asked to do here is identify the values of h and k for every situation in example 7, and then write the equation of the transformed function, okay? And I'm hoping that at the end of this, your question about f the answer will be clear in your head. So I would like you to look up here, please. Don't look at your paper. A says we have a function that is y equals 1 over x, and it is transformed by translating it 4 units up and 3 units to the left. I want you to look at the screen and how I'm going to change the question just temporarily. If I said a function is translated 4 units up and 3 units to the left, we could figure out what h and k are. Yes? It doesn't matter right now that we happen to know the specific function is 1 over x. It doesn't matter whether the function is 1 over x, or whether the function is x squared, or whether the function is sine of x. If it's translated 4 units up and 3 to the left, then we know that h is negative 3 and k is positive 4. Just let that sink in. Okay. Now what this means, when you look at the template, and if you're watching this on video, you're just going to have to verbally or listen, audit with your ears. Well, I don't know how else you would listen. You're just going to have to listen to the words rather than see it. We have a template that I'm referring to on the left side of the classroom that says y equals f of x minus h plus k. So let's load these two parameters into that function template. And what's going to happen is we'll get y equals f of, and watch how I write and say this, f of x minus negative 3. X minus negative 3 becomes x plus 3. Close brackets plus 4. So we're going to actually move on to b now. We're not going to really answer a. We're just going to say that if any function in the universe is translated 4 units up and 3 to the left, this will be the equation of the new function. Okay? We'll come back to the true question A in a few minutes. When you look at B, B says y equals the absolute value of x, and we're going to translate that 5 units up and 2 units to the right. Well, the fact of the matter is, it doesn't matter what the function is. If any function is translated 5 units up, k is positive 5. And if it's translated 2 units to the right, h is positive 2. Because up is a positive direction and right is a positive direction, both of those parameters are positive. So if we load both of those parameters into our template, the template is y equals f of x minus h, which is 2, plus k, which is 5. So any function, I know we're talking about this specific function of y equals the absolute value of x, but any function, which includes the absolute value of x, that is translated 2 to the right and 5 up, will have that equation. Y equals f of x minus 2, close brackets, plus 5. Are you still with me? Okay. And I think you see where this is going. Let's not talk about the specific function of y equals x cubed. Let's talk about any function that's translated 6 down and 1 to the left. Well, if it's translated 1 to the left, h is negative 1. If it's translated 6 down, k is negative 6. And I hope everybody agrees with that, because if you're confused about that, then you missed the whole point of yesterday's lesson, or one of the points of yesterday's lesson. So are we okay with that? I haven't made a mistake there, I don't think. Okay. So loading that into our template or our general formula, it's y equals f of x minus negative 1 and then minus 6. And let's do d that way as well. I know that the specific function is the square root of x, but I don't care about that in the identification of h and k. It doesn't matter. Something that is shifted 8 units down will have a k parameter value of negative 8. And 2 units right will have an h parameter of positive 2. Which means that this is y equals f of x minus 2 minus 8. Are you with me to this point? Because the leap we're going to make from this to the specific functions addresses Ian's question, and it's a complicated thing. So it's not easy to understand all the time. So we're okay with all of that. Okay. So now I'm going to go back to A, and I'm going to write up here. You've already got it written down, but I need to write it down so I can see it. I'm going to write what we decided was true for any function that undergoes those transformations. Did I write it down correctly? Okay. Now, the function we have here is y equals 1 over x. This is an advantage to having function notation. When you were first taught about function notation, f of x, your teacher probably said, if you're really confused by it, just remember f of x is y. You remember that? F of x is another way of writing y. So I am going to write this as f of x equals 1 over x. All right? All I'm doing is I'm rewriting the original function to include function notation. Yeah. Back to which one? D? Now I'm going to review some stuff about function notation. Are we okay back there? Okay. I'm going to review some stuff about function notation. And this is crucial. If I said to you that f of x is 1 over x, and I said determine f of 3. Let's just say I said, what is f of 3? Well, what f of 3 is the result of changing the x. Look up here. I'm pointing at an x. The x changed to 3, didn't it? So if f of x is 1 over x, f of 3 is 1 over 3. If I said to you, what is f of a, I better not use a, f of r, well, it's 1 over r. F of a thing means you substitute that thing in for x in the original function. And that, what I've just said, should ring a bell. And you're used to in 10 and 11, grades 10 and 11, using numbers like f of 3, f of 8, f of negative 2. But I could put f of puppy. If f of x is 1 over x, then f of puppy is 1 over puppy. Let's not bend our brain in half trying to figure out what that means. Math is all symbolic. Squiggles on paper. Puppy means whatever I want it to mean. Just like A means whatever I want it to mean. 3 means, well, 3 is 3. R's are. These different things represent, sorry, let me get that screen back. These different things represent something. And in the case of 3, it represents the number 3. In the case of R, it represents R. In the case of puppy, it represents puppy. It doesn't matter what it is. Okay? So, look at what we wrote here on the right-hand side of the screen. We said the equation of this function, of any function that undergoes these transformations, is y equals f of x plus 3 plus 4. But if f of x is 1 over x, then this is 1 over x plus 3. So wherever there was an x in the original function, we put x minus h, because it's f of x minus h. Any questions with, this is our answer, by the way. This is an answer, but it's not specific enough to this question because we happen to know what f is. F is 1 over. Go ahead, Ian. No. It's one or the other. It's this or it's this. And I'm going to come back. You remember that question that you asked, but I'm going to come back to it once we've done all four. Okay? So I'm answering your question by saying no. That's the answer. I will give an explanation later. Okay? When we look at this, y equals the absolute value of x, and we decided the new function was y equals f of x minus 2 plus 5. Did I get that right? In this case, f of x is the absolute value of x. So what f is the absolute value. F is an operation. It's a function. What's the operation or function? Absolute valuing the input. So f of 5 would be the absolute value of 5. F of kitten would be the absolute value of kitten. F of x minus 2 would be the absolute value of x minus 2. So again, this equation here is an answer to this question that's not specific to the question. It's specific to any function undergoing these transformations. Since we know what f is, we can apply the operation of f, which is the absolute value. So I'm going to start to answer Ian's question that he had a minute ago. Visually, by saying that this is 1 over. That's what f means. It means 1 over. This is the absolute value. So we don't write the f with the absolute value, and we don't put the absolute value up here with the f, because they mean the same thing. You write one or the other. When we take a look at C, we decided that the new function is f of x plus 1 minus 6, correct? Okay. Well, in this case, we know what f of x is. It's x cubed. So f is cubing. That's what f means. It's the operation on x, which means that this becomes y equals x plus 1 operated on, which is cubed, and then minus 6. Again, the f means cube the thing. And again, this is an answer that is not specific enough for this question. This is the more specific, better answer to this question. Finally, for D, we ended up saying that y must be equal to f of x minus 2 minus 8. Yes? In this particular case, even though it doesn't say f of x equals root x, if y equals root x, f of x equals root x. So when I say to you, what is f? F means square root. So f is going to mean square root of x minus 2. And then we have our minus 8, and this is y equals. So there's our answer. Now, I think I've answered your question, Ian, and I don't want to spend too much more time with this, but normally, had somebody not asked about this, I wouldn't have been connecting f with the square root, and f with the cube, and f with the absolute value, and f with the 1 over. What I would have said to everybody at this point in time, and I always start with this one, as I say, some people will say to me, "Oh, Mr. Way, you made a mistake." What's the mistake? You forgot to put the cubed up here. And I will ask my class the following. I did not make a mistake. If I put a cube there, I will be making a mistake. And the question is, why don't I put a cube there? And the answer is because it already is there. This means cubed. And we can see it means cubed because f of x is x cubed. Have you got that sorted out now? Okay. All right, let's move on. Let's take a look at the next question. We've got two more, I believe. And these questions will then allow you to answer the next problem, Madison, that you were asking about. I've taught you, if I taught you Math 20, put up your hand if Mr. Hetlinger taught you Math 20. Put up your hand if somebody other than myself or Mr. Hetlinger taught you Math 20. Okay, who was it? Mr. Flynn? Okay. I teach something in Math 20 that I don't know if they do. It's not that they don't teach you something they should. I teach something a certain way. So when we, and that will become clear for those of you that I've had in my class in a couple minutes. What vertical translation is applied to y equals x squared if the new graph passes through 5, 12? If you approach this as some kind of a puzzle, then every question will be different. You know what I mean by a puzzle? You just go, well, let's see, what might it be? And you get out some graph paper and you graph x squared and you try to count squares or something. It's not a very efficient way to do it. What you need to do is understand that the new function is y is equal to f of x plus k, because there's a vertical translation. It doesn't say there's a horizontal translation, so we're going to assume there isn't. It says what vertical translation is applied to it. Now we're going to do the same thing that I kind of talked about in the previous example. We need to think of this as f of x equals x squared instead of y equals x squared. We're going to think of it as f of x equals x squared. And that means the new function is y equals x squared plus k. This is the new function. And this is our goal. If we can determine the value of k, we know the answer to the question. If k is 12, then we have to shift the original function 12 units up so that it will pass through that point. Now, does anybody remember how we can use this to find k? And I'll give you a hint by using the language that I use in my Math 20 class. It's a missing parameter. And when I taught this to you in Math 20, I said, you know what? We're going to have to find missing parameters in Math 30. And the missing parameters are always found using the same technique. Does anybody remember what we can do here? Madison? Right. You load in an ordered pair that makes the equation true. And an ordered pair means an x and a y value. And if it makes the equation true, that means it's going to be a point on the graph. Well, we're told that this thing contains 5, 12, which means, and this is, you don't necessarily need to see it this way that I'm going to show it to you, and your teachers may not, unless you had me, have always done this. But I think it's very important for you to understand what this means. It means when you put 5 in for x, you will get 12 for y. That's what 5, 12 being a point means. It means when you put 1 in, you have to get the other. And once you see that, this question is not difficult mathematically. Oops. I know that you do not need to put brackets around the 5 because it's a positive number. When you square it, it doesn't matter. But I would like you to get in the habit of always putting brackets around something that you substitute in for a variable. And this is also, if you haven't had me for math teacher before, I'm a big fan of the idea in math of taking something and turning it into a problem that you could have solved at an earlier level. We have gone from really a math 30 concept and used a math 20 approach to get a grade 6 question. Really, I mean, I don't know if you want to worry about is it grade 6 because of the squared or not, but if you have 12 equals 25 plus k, that's a pretty simple question. It's not something that you would have a lesson on in high school math or even grade 9 math. You should know that we can subtract 25 from both sides. So k will be equal to negative 13. The answer to the question is 13 units down. And we can verify that. We can graph, oh, sorry, buddy. We can graph y equals x squared minus 13. I'm going to go zoom standard, and then I'm going to adjust my window settings. Now, this is supposed to pass through 5, 12, right? So I guess I can just go trace 5. It shows me the y coordinate is 12. I can't see the point because it's off the screen. I could go to my table and look at x equals 5 and see that y is 12. There are ways that we could confirm this. Any questions with that example? Okay. Same type of question with number 9. We're dealing now with a horizontal translation. So as soon as you see a horizontal translation, you're going from y equals f of x to y equals f of x minus h. This is the new function. The original function is f of x equals x squared. That's just a note for me. So if f of x is x squared, then f of 5 is 5 squared, f of goldfish is goldfish squared, f of x minus h is x minus h squared. This is our goal this time. And it's a missing parameter. That language is, you're going to see missing parameters. This language is important. You'll see missing parameters in trigonometric functions, in logarithmic functions, in exponential functions. You'll see them over and over again. So how do we determine the missing parameter? We load in an ordered pair, which in this case, the ordered pair will be 10, 9, because if the graph passes through 10, 9, when x is 10, y will be 9. When you put 10 in for x, you have to get 9 coming out for y. So we end up with this equation, which we have to solve. And at least we've left the realm of math 30-1. We're in a realm of quadratic equations, which is 20-1. So I am going to solve this in 2 ways, and then I'm going to ask you why one of the methods contains an error. I'm going to expand this out. Don't forget that 10 minus h quantity squared means 10 minus h, 10 minus h. You want to see your math teacher, that forehead in your math teacher's, that vein in your math teacher's forehead start bulging? Write something like 100 minus h squared, because that's wrong. When you square a binomial, you have to take that binomial and multiply it by itself. We see that this is a quadratic equation because it contains a variable squared, and the general rule for a quadratic that you learned about last year is you zero the equation. We need to get everything on one side of the equation. I prefer to put things on the side of the equal sign so that my quadratic term is positive. And since it's already positive h squared on the right, I'm going to leave it on the right. I have minus 20h. Then I have plus 91. Because I have to take 100 minus 91. Is this factorable? Are there two numbers that multiply to give 91 and add to give negative 20? Seven and 13. I'm not going to do the b. How many of you did b squared minus 4ac to check? Anybody? How many of you know what I'm talking about? Okay. I'll review that tomorrow. There's a trick with b squared minus 4ac. But in the meantime, you said 13 and 7. Okay. So this factors into h minus 7 and h minus 13, which means I do want to review a little bit of why what I'm about to write works. It means that h equals 7 and h equals 13. Because since we're multiplying these two things together, if one of them equals 0, then the product equals 0. So what I'm saying is if h minus 7 is equal to 0, then I don't care what h minus 13 is. 0 times h minus 13 will make it 0, which makes it true. And h minus 13 equals 0. It's that idea again. Math 20-1. Kind of 10C factoring. Man, I want to say math. I'll say math 5. You explain to a grade 5 student that you have a number and you're going to take 7 away and you're going to be left with 0. What was the number you started off with? 7. You know, we have a more symbolic way of solving this. Sometimes we don't even think about it. We just go, well, let's add 7 to both sides. Anyway, those are the two solutions. Now, why do we get two solutions? One is 7 units to the right, and one is 13 units to the right. How can we get two answers? They're both legitimate. Well, let's look at graphing. Y equals f of x minus 7, which would be x minus 7 quantity squared. Now this is supposed to go through 10, 9. So I'm going to change my window settings to go up to 12 for x. You don't have to worry too much about this. I'm also going to plot the point so that you can see it. I'm going to plot the point 10, 9. Don't worry about what I'm doing here. It's not important. I just want you to be able to see the point. I got some other data in here somewhere. Oh, there we go. So there's the point, and the graph passes through it. Just in case you can't see that point, it's right there. It's that box. Now I'm going to plot. How many of you know why the second function will also go through there? Let's look at the second function. In fact, I'm going to put it on the same set of axes. The second one is x minus 13, quantity squared. The idea is since the parabola has two branches to it, a left and a right, we can shift it 7 units to the right so that the right-hand branch crosses that point. Or we could keep going and go 13 units to the right, and the other branch, the right-hand branch, crosses through it. Left-hand branch, rather. So any questions with that example? I said I was going to do it another way and then ask you why I have an error. So I'm going to start off with the 9 equals 10 minus h quantity squared. And this would be something that if you weren't paying close attention in 20-1 you would do, or if you hadn't taken 20-1 you would do. You'd say, well, I'm going to take the square root of both sides. That gets rid of the squared. I'm left with 9 equals 10 minus h. I'm left with 3 equals 10 minus h, because the square root of 9 is 3. I don't like negative h's, so I move it to the other side where it becomes positive. Well, I add h to both sides. I don't want to have to worry about negatives, so I get h equals 10 minus 3, and I get h equals 7. One of our answers was 7, wasn't it? Okay. How come I didn't get 13 as well? There's a huge mathematical error in what I've done here somewhere, because I know there are two answers. I know there are two answers. I can see it. What did I do or not do? Pardon? I did. But why did a quadratic turn into a linear? There has to be a mistake. Yes, I ended up with a single linear, but why didn't I get two linear? You know? Plus or minus. When you take the square root, when you introduce the square root of something, you have to go plus or minus. So what we end up with is this. And that means 3 equals 10 minus h, and negative 3 equals 10 minus h. And then you'll get the 7 in one and the 13 in the other. I only have one more thing to say, and then you'll have about 15 to 20 minutes to work on the practice problems today. But before I do, any questions at all with any of the examples or the content today? I want to go back to, say, this question. So I'm going to highlight the original function. I'm going to highlight the original function in, not brown, in yellow. This is the original function. O for original. And I'm going to highlight the transformed function nice. I'm going to highlight the transformed function in blue. And if you don't fully pick up what I'm about to explain, that's okay. This is the transformed function, T for transformed. But if you do pick up what I'm going to explain, it's a bonus. It'll be helpful for you. In each of these functions, x is the same thing. Meaning, the x in this function is the x value here that you're adding 3 to. Okay? But the y's are different. The y on the left is the y you get when you divide 1 by x. The y on the right is a different y because it's a different function. So this is where confusion comes in, because it turns out the two x's are the same. They really are. And don't worry about why exactly. But the more important point is the two y's are different. And this is why, or how come, we decide to write this y as f of x, and most of the time choose something else for this y. And Ian, you and I were having a conversation about this kind of thing yesterday. So because the y's are different, it's almost better to write g of x or h of x or p of x, which is why if I go to this template and I will write it down, the template is y equals f of x minus h plus k, which is how it would appear on a formula sheet, to be fair. But really, this is better, because then you can say f of x is the original, this is the transformed. So when you see that g of x, it's just the new y, that's all. Don't get confused by it. In other words, when we tell you in earlier grades, oh, f of x is y, well, if you have another y, then you need another function. Call it something else. Call it g of x or h of x or q of x. So that might clarify some things as well. In the meantime, and in between time, before we get to tomorrow's stuff, you have some practice problems that are textbook and multiple choice questions. Do not minimize the importance of textbook problems. I've kind of told you, and I'm sticking to it, that this is not all homework. But what I will tell you is you need to know how to do all of them. So what that means is you might look at question 5 here and go, yeah, I'm pretty sure I understand what we're doing. This is just like the example Mr. Wade did today. And maybe try B or D or something and make sure you know what's going on. And you might try number 6 because that's like an example, and number 7. But then you get to number 17, and we didn't do an example like number 17. So you better try number 17 for tomorrow. Okay? And I'm sure that I will be going over number 17 on the board, but I want you to give it the old effort first. Anyway, how do we do here? Yeah, you got about 15 minutes to work on this stuff today. And I will get your quizzes back to you probably by the end of the class.